In lesson 3 of chapter 8, labor mobility, we're going to estimate 3 regression models. We're going to predict the immigration, the in-migration, out-migration, and net migration. And in-migration is the number of people who migrated into a state per 1,000 residents. And that's from the American Community Survey. Out-migration in 2019 is the number of people who moved out of a state per 1,000 residents. Net migration is the difference in these two. And our independent variables are the business tax climate, the state unemployment rate, the state share of residents who had a bachelor's degree or higher, homeownership rate, the log of the state median household income, the poverty rate, and the economic growth rate. The first regression we're going to do is, like I said, in migration. The data is at the bottom down here. We're going to copy all the data down here. And I'm copying all the data and then something outside the table so that I preserve the table formatting. I copy that and paste it to Excel. I'm going to right click and then paste special match destination formatting. Then I'm going to highlight all the data. Highlight all the data here. Then we go to home. And I'm going to click on format as table. And when you do this, it's pretty cool because, as I've demonstrated in the past, you can sort things, like you can sort lowest to highest. And you can see that DC, Wyoming, North Dakota, Arkansas, Idaho, Nevada, Colorado, Delaware, Montana, New Hampshire are in the top 10 of in-migration. For out-migration, you have DC, Arkansas, Hawaii, Wyoming, North Dakota, Montana, Vermont, Colorado, Nevada, and New Mexico. I noticed that DC is the top out-migration and in-migration, which makes sense because there's a lot of political turmoil in DC, a lot of turnover, right? One party moves in, one party moves out. So there's a lot of churn in DC. We may want to consider dropping it from the data set. And then for net migration, the net migration is just the difference in these two. So you take the in-migration, subtract out the out-migration, and you get the net migration. And then the state with the best business tax climate is the one with the highest number, Wyoming, then San Diego, South Dakota, Arkansas, Florida, Montana, New Hampshire, Nevada, Utah, Indiana, Oregon, North Carolina, etc. Right? The ones with the most restrictive business climate are New Jersey, New York, California, DC, Connecticut, Iowa, Minnesota, Louisiana, Arkansas, and Vermont. That's the top 10. That's the bottom 10. The unemployment rate, Hawaii, North Dakota, Vermont, Iowa, New Hampshire, South Dakota, Nebraska, Idaho, Utah, and Minnesota are the top 10 of unemployment rates. The economies with the largest unemployment rates are Alaska, DC, West Virginia, Mississippi, New Mexico, Arizona, Louisiana, Ohio, Illinois, and Nevada. And Nevada is tied with several states, right? Then we have bachelor's degree or higher. And the top 10 are DC, which makes sense because you have all those government jobs and politicians or lawyers and etc. So that totally makes sense. It's quite a bit higher than the second place state, Massachusetts, and then you got Colorado, New Jersey, Maryland, Connecticut, Virginia, Vermont, New York, New Hampshire, right? They're the top 10. Home ownership rate, the lowest is DC, which helps explain why those are so large, right? By why both of those are so large. Not a lot of people own homes in DC. Probably because people go to work there for 4 years and they leave, right? When their party's no longer in power. Homeownership rate in the states, in the 50 states, New York and California are by far the states with the lowest homeownership rates. The states with the highest homeownership rate are West Virginia, New Hampshire, Michigan, Mississippi, Utah, South Carolina, Vermont, Maine, Wyoming, and Delaware. And then in terms of, this is the log median household income, right? So this is in log dollars. And the states with the highest household income are Maryland, Massachusetts, DC, New Hampshire, Hawaii, Washington, Utah, Virginia, New Jersey, and Connecticut. They're the top 10. Connecticut's tied with Colorado in terms of log median household income. And then we got poverty rate. The highest or the lowest poverty rates, which is good, New Hampshire, Hawaii, Maryland, Utah, New Jersey, Minnesota, Colorado, Massachusetts, Washington, and Connecticut. The states with the highest poverty rate: Mississippi, New Mexico, Louisiana, West Virginia, Alabama, Arkansas, Kentucky, DC, Oklahoma, and South Carolina. And then we got the economic growth rates. The economies that are growing most rapidly in 2018, Washington, Idaho, Utah. I lived in all 3 states at one point. Texas, Colorado, California, Arizona, Oregon, Massachusetts, and North Dakota round out the top 10. Okay, so that's the data set. And then what we want to do is we want to create a regression. And we're going to use in-migration as the Y variable, and then everything over here is going to be independent variables, the X variables, okay? So we're going to go data, data analysis, regression. I'm going to highlight the in-migration. Now, you might have to watch this because I'm going to let you guys do on your own out-migration and net migration. I'm going to help you do the in-migration first. Okay, so we got the Y variable determined, right? We got it loaded. We click on labels because we're including the name, right? And then we're going to grab the independent variables, the X variables, including the names, the labels. So we've got labels. We're going to click on output range. We're going to put the output right here in M1. Okay, we're going to put the first regression here. And then everything looks good. We're going to OK. And then I'm going to widen this up over here. I'm going to auto fit the columns. I'm going to grab all these decimal values. We're going to reduce them to 3 decimal places because that's what my method's calling for. So home number, reduce the decimal places to 3. Let me auto fit that again. We don't need the prediction and confidence interval, so let's get rid of that. Okay, and there's our results. I'll mark the coefficients that are statistically significant at the 10% level. Red and bold. And then we fill in the information here. The R square is 0.442. And it's not as close as I like to see it to adjusted R square. Remember R square, you can inflate R square just by adding a bunch of variables that have no predictive power over the thing that you want to predict. So, and that makes sense because we have more variables included that are highly insignificant than we have. So we have 4 variables that are highly insignificant and 4 variables that are significant at the 10%, or 3 that are significant at the 10% level. So that kind of helps explain why maybe this adjusted R square is a lot lower than R square, right? The F statistic is not as big as it has been in past regressions we've run. We've seen the F stat as big as 90, right? It's only 4 here. The p-value is still the p-value of the F statistic is still essentially 0. And that's because we have 3 predictors or 3 coefficients that are significant, right? So these 3, and this one's pretty significant here, right? The p-value is really close to 0. The test statistic is fairly large, right? So that would explain this, right? What we generally want to see is these two being pretty close to each other and then a very large F statistic. And that's what you're looking for in practice, right? Okay, so the F statistic is 4.861. And the p-value is 0.000. I'm going to go ahead and fill in these values. So I'm going to be on pause and I'll fill these values in. Okay, I pasted in all the copy and pasted in all the p-values and all the coefficients. Now we want to interpret the results, right? So for the following, test all hypotheses at 10% level. Now on this first one, this first answer box, after we've inserted in the information, we want to interpret the coefficient of variation. And so one way to do that, the adjusted R square, we want to, the first answer box after all the regression output has been inserted above is the adjusted R square, right? We got to turn it into a percent. Okay, so I'm going to click on that and then turn it into a percentage and then add a decimal place because it's asking for 1 decimal place. So the adjusted R square implies what? And we don't need a percent symbol because we already have percent right there, right? So the adjusted R square implies that 35.1% of the variation in migration. See, in migration varies, right? It varies from state to state, right? 35.1% of the variation in migration can be explained by the model, the linear model, right? And it's linear in these variables. Okay, so it's only 35.1%, right, of the variation in this that is explained by these variables, right? We've had regressions in the past that had a higher adjusted R square, right? Now the p-value of the F statistic, which Excel calls significance F, the p-value is 0.0, right? And that suggests what? Well, the null hypothesis for the F test is that this coefficient, this coefficient, this coefficient, all of these coefficients, right? Here are the estimates. These are the estimated coefficients. When you're running the F test, you're saying that this is 0, and 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 this is 0, right? And we're going to reject that because the p-value is so small, and the F statistic is way up in its distribution, right? If none of these variables did a very good job of predicting in migration, the F statistic would be closer to 1, and the p-value would be a lot larger, right? But we do have some significant predictors here, right? Which means our F statistic is fairly large and our p-value is really small. So we have evidence in support of the we have evidence that rejects the null hypothesis on the F test, right? And we conclude that our model is significant. And there were 3 coefficients or 3 predictors that were significant, right? At the 10% level, 3 of them. Now below, if the predictor is insignificant at the 10% level, we're gonna enter 0 in, right? So we're gonna enter a 0 for the unemployment rate. So the unemployment rate is there. We're gonna change that to 0 because we're insignificant at the 10% level. We're gonna do the same for the log of median household income, 0. And then poverty rate, we're gonna say 0. Because this was insignificant, right? At the 10% level. And the final one is the economic growth rate. We're gonna say that is 0, right? Whoops. Okay, so we're gonna check all those. Okay, so our insignificant ones, we made the effect 0. So now we gotta interpret the results of the ones that are significant. So this implies here, we're gonna copy it. That implies that a 1 unit improvement in the business tax climate index increases in migration by 8.417 people per 1,000 residents, right? All right, so the next one, the share of people in a state that have a bachelor's degree or higher, right? So 1 percentage point increase in the share of residents with a bachelor's degree or higher increases in migration by almost 1 person per 1,000 residents, right? A 1 percentage point increase in home ownership rate. Now this coefficient is negative, right? So we have increase right there, decrease there, right? Because this is saying a negative relationship, right? So what we're gonna do is we're gonna copy and delete the negative sign. So 1 percentage point increase in the home ownership rate decreases in migration by 0.604 people per resident, right? Per 1,000 residents. Okay. And then I want you all to do the out migration, right? So on the out migration, what you're gonna do is you're gonna click on data. Let me wipe this up. Data analysis. You're gonna click on regression. Instead of using column B, you're going to use column C. So you're going to highlight everything from OMIG down to the last value in the column, right? You're going to grab that last value in the column. And then I want you to put it down here below the first set of regression results, right? And I have it in cell M26, right? And then hit OK. And then for the third regression, you're going to do net migration. So on that third regression, right, you're going to click data, and then you're going to do data analysis, regression. And instead of using column C, you're going to use column D. So you're going to go from NMIG down to the last number in this column, right? So that's your new Y. Your X always stays the same, right? The X range always stays the same. We have labels, output range. And then I'm going to put this output, I'm going to hit backspace here. I'm going to put it right below regression 2, right? And then hit OK. So you're going to have the out migration results, the net migration results, the out migration results, and then these are the in migration results. Okay.